We're going to learn how to delineate watershed of a catchment of a desired area or a study area. If it is the catchment of my study area and I want to delineate its watershed of a particular tributary or a stream, so how can I delineate it? By using DEM file via ARC GIS. So we're going to see. Let's start it. Open my ARC GIS file, new blank map. Then my folder. Where is my DEM file? So here it is, my DEM file of a study area, which is digital elevation model. You can download it by USGS site, but it would be of low resolution, which is 30 meter. And if you need to download a DEM of a high resolution, you need to purchase it from a satellite company. So we're going to start it. First, I have to see its projection according to my zone or area. Go to right click anywhere in a space and data frame properties, coordinate system, projected coordinate system, go to UTM, WGS 1984, Northern Hemisphere and 42N. As my area lies in Northern Hemisphere and 42 UTM zone. Now I have to convert it to raster, export data, data frame current, name file, study area, DSM. Would you like to just put it map areas? So we're going to remove the previous layer, and now we go to ARC tool. Here we can see spatial analyst tool. Go to hydrology and click to fill, which is our first step. Drag your raster file here and name the output file as a fill. Yes, now we can save it. It takes a bit time to convert it to fill as my system specs are low, so we have to wait until our western tributary of this Nala. Here is two tributaries, eastern and western. So I'm going to delineate its watershed. So here we go, fill file. Now we go to flow direction and input surface raster. Drag your fill file here, output, and named it as a flow direction and save it. Okay, now it is in process. You can see it here, flow direction. So it also take a time, as my DEM file is so much heavy due to its resolution. It is 0.3 meter of resolution. Now it is implemented overall my DEM file. So now the third step is of flow accumulation. So input flow direction raster. So drag your flow direction file here. Output accumulation raster, named this as a flow accumulation and save it. Okay. Now it is in process and making a flow accumulation. Now flow accumulation is completed, as you can see here. Now this is the flow accumulation file. Now we're going to map algebra and spatial analysis tool. Map algebra raster calculator. Go to condition. Check it to flow count is greater than 300 and is equal to 1 true. And output location DSM new, and save it. And it is now calculating the raster calculator. So if you disable all files, here you can see the string patterns of your DEM file. I'll make it more zoom. Yes, here it is. You can see the string pattern of your, but it is not much visible. To make it more visible, go to spatial analyst tool, hydrology, and stream to future, and import a stream raster, put it there, and put flow direction, Yes, and make another file, named it as a feature, and save it. So it is processing right now, and we have to wait until it is done. After which you can see the stream pattern of our DEM file. It's quite visible. It's done now. And if you can zoom, so here you can see the western tributary of that Nala of my study area. It is here, it is a western tributary, and by clicking ARC GIS, here you can see it clearly. After that, we need to mark the outlet of which we need to delineate watershed. So open a catalog, my connection folder, which is watershed delineation study. Make a new shapefile and name it as a outlet. Feature is point, set a coordinate system, projected coordinate system, UTM, WGS 1984, Northern Hemisphere, and 42N zone. Yes, here it is. Now make it OK and mark a point of which we need to delineate watershed. So editor, start editing. Feature, now outlet. Okay, select your now chart editor. We need to select a point. Mm, so it, first we have to delete this. So okay, fine. And open from here and select a point and make a point here for which we need to delineate and then stop before stopping edit, save it and then stop edit and change the symbol so it may be dominant here. Now we open ARC tool and hydrology and go to watershed. Now input flow direction and drag a flow direction, drag a point of which you need to delineate watershed and name it a watershed and save it. So it is in process. Now it is implemented and you can see the watershed of our catchment of a western tributary we mark and now convert the data, convert this raster to polygon, go to conversion tool, from raster to polygon and import the raster, input this watershed here and make a new file of polygon and save it and convert it to polygon. So we can change the color, fill no color, outline, make it a red or some other color which would be prominent and increase the width of the boundary. Here you can see and remove the previous layer. So it is very easy to understand. It is basically the watershed of the western tributary of this Nala. So further we need to clip this area for which we will go to analyst tool, extract and clip and clip this file. So input feature, we're going to add clip feature boundary and input a feature is this and named it watershed of study area. Save this file and it is now being converted. So it is clipped from the sheet. So we're going to disable the other files so we can see our watershed clearly. Here it is, and to see if it is really or actually implement on the ground, so we're going to convert into KML file so we can open it on the Google Earth in our catchment area. So layer to KML, drag your watershed in here and change its name named Watershed Eastern Tributary. Save it and make it okay. Now the process layer to camel. It is now converted to camel file. Now we go to our folder, Watershed Delineation, and see where it is. It is Western E Tributary. Open it on a Google Earth. So here it is. Make it dominant, change its color, make it blue, and increase its width. Now see that the watershed, I am near the watershed of western tributary of this Nala, and here you can see the stream orders and the complete catchment, how the water accumulates and downstream side towards the stream. So you can delineate all the watershed of your catchment where you want to by this process via DEM file using ARC GIS. But one thing you need to understand that my DEM file is of higher resolution. That's why my watershed is so precise. You can see each stream is perfectly on its way in the catchment, while the open source DEM file is of 30-meter resolution, which might show some displacement or errors. Thank you.